Hey everybody, it's Mr. Carr again. Today we're going to be looking at 4.2 day one, finding a least common denominator. Okay. Now, in the past, you've done it with problems like this for adding and subtracting. So without a calculator, I'm going to find a common denominator and I'm going to focus on 5 and 6. So I'm looking for something they both multiply up to. So 5 and 6 is going to be going up to 30. So if I multiply this by 6 and this by 5, they both turn into fractions over 30. But when I multiply the denominator by a number, I have to multiply the numerator by the same values as well. So 6 times 3 is going to give me 18. 1 times 5 gives me 5. Once we have common denominators, we just simply add across. So 18 plus 5 is going to give me 23 over 30. Okay, over here, we can also just turn the 8 into 24. And we're looking for at least common denominator to make it easier on ourselves. So I multiply this by 3, that's going to turn into a 24. But I have to multiply the 1 by 3 as well. So I'm going to have 13 over 24 minus 3 over 24. So then I can combine these. So 13 minus 3 is 10 over 24. And we like to make sure to reduce our fractions when possible. So 10 and 24 are both divisible by 2. So I do that, and I end up with 5 over 12. Concepts today are very similar. We have to be able to make our denominators into similar things. So in this case, they already are. We can add and subtract as long as we have our like denominators. Okay. So when I do this, 4x and 4x is just going to stay 4x in the end. My numerator is now 7 plus 3 to give me 10. So, but then always check to simplify. 10 and 4 are both divisible by 2. So if I do that, I get 5 over 2x. So x does not combine with anything. We're just done there. With this one, we have common denominators, but I got to be careful because I'm subtracting my second fraction, which means I'm subtracting the entire numerator, which means it looks like this. I am subtracting 5x minus 1. So what's going to happen here is 2x is going to be subtracted by 5x and then added by 1. And the whole thing is over x plus 6. Okay, so I'm basically doing this distribution with a negative sign like that. So now if I put it all together, I got 2x minus 5x is a negative 3x plus 1 over x plus 6. There is no simplification to do. My factors are negative 3x plus 1 and x plus 6. They do not reduce. So this problem is done like that. Okay. So when the denominators are not the same, though, we need to make them into the same thing. So we still want to find our least common denominator. It just looks a little different now versus when we did just fractions. So if we look at this, we first, if need be, we have to factor. Okay. We don't have that in this case, so we'll see that in a different example. Find the least common denominator of the coefficients. So in this case, 5 and 15. Since I can turn 5 into 15, my least common denominator is going to have 15 in it because 5 can turn into that. Then the other part is the variable part. It's so the variable part of our least common denominator will be every variable you see with the highest exponent. The reason why it's the highest exponent is because I can make x into an x squared. I just multiply it by another x, but I cannot really do it the other way around. I don't want to divide out by an x. So that means that 15x squared is my least common denominator. For this type of problem, that's all I need to do. I just need to find the least common denominator. The next step would have been, which actually that's all we're going to cover today. Yeah, we'll just leave it at that. We're going to just find the least common denominator. Okay. Find the least common denominator here. First step is to factor. Some of these are already factored, but this part is not. So that's the difference of two squares. So it turns into x minus 2 and x plus 2. Find our least common denominator of coefficients. So I have 2, technically I have a 1, and I have a 3 here. So my least common denominator is going to be the common denominator for 2 and 3. They both can multiply up to 6, so 6 is going to be a part of that. Then I'm going to look at the variable part. So every highest exponent I see. So x and x are both raised to the first power, so I'm going to have an x as part of my LCD. Now, when it comes to the other factors, though, we got to be a little bit careful. We're basically going to represent every single thing here, each individual thing that shows up in our least common denominator, but it only shows up the one time. So if I have x minus 2 here, and I have it in here in common, I'm still just going to write it one time like this. I have x minus 2 as part of my LCD. I also have an x plus 2, which is also here and here. So that's a part of my LCD. So this is the entire least common denominator. It's made up of 6, x minus 2, and x plus 2. Finding it here, again, we need to start with factoring. So I'm going to go ahead and do that here. I can do my GCF factoring, which is 4 times x squared minus 4. And that's going to be x minus 2, x plus 2. Here I could factor a 6 out. So it's going to be x squared minus 4x plus 4. And then I can factor this because what multiplies to 4 and adds to a negative 4 is going to be x minus 2, x minus 2. Now we look at our coefficients, 4 and 6. So what is the least common denominator, or what's the least common multiple they can multiply up to? That's going to be 12. So 4 times 3 is 12, 6 times 3 is also 12. What do I have in common? So I have x minus 2 and x minus 2. So I'm going to write it one time like that. But I also have another x minus 2 here. So because that one has that, I can technically write it as x minus 2 squared. So I need to include both x minus 2s as part of my LCD. Okay, it's kind of like the same idea as this is the highest exponent. My highest exponent for x minus 2 is this x minus 2 squared. And I still have an x plus 2, so that's going to be part of it as well. Okay, and that is it for today. So we're just trying to find that least common denominator. So again, these 3 ideas right here, make sure you're doing that every time. You're going to start with factoring. You're going to find the least common denominator of coefficients. So that's the numbers that they can both multiply up to. And then we want to look for the highest exponent when it comes to our variables. Sometimes they're a little bit easier like this, where it's just x squared versus x. X squared is the highest, exponent. But this one, keep in mind that if I'm multiplying x minus 2 by itself, that's the same as x minus 2 squared. So technically, that's my highest exponent. So that's why I include that one. All right. And that is it for today. So take care, everyone.